Hello everyone and welcome to my channel Commerce with Vijayalaxmi Baddi. Today we will be taking up M into 2 games under game theory. So under graphical method we have two types of games, 2 into n games and M into 2 games. In the last video we have taken up a problem relating to 2 into n games, and here we will be discussing about M into 2 games. So M represents the number of rows and 2 represents the columns. So under this type of games we will be seeing that the columns, number of columns will be 2, while there can be any number of rows that is relating to player A. So let us take up the problem. Find the solution of the following game theory problem using graphical method. So we can see here in this problem, player B is having only 2 strategies, that is the columns. We have 2 columns, it means 2 strategies, while player A is having 6 strategies. So M represents the number of rows, which can be of any number. Now these are the outcomes which are given. So first step here, we need to check for the saddle point. So whether the problem is pure strategy or mixed strategy, the first step will be to check whether there exists a saddle point. So let us take and find out whether there is a saddle point. To find out the saddle point, we will take row minimum and column maximum. So row minimum, we will take the lowest of each row. So 1 and minus 3, 3 and 5 is 5, then minus 1, 1, 2 and minus 5. So column maximum, so maximum values for the each column. And here the maximum value for the first column is 4 and maximum value for the second column is 6. Let us see whether we can reach at the saddle point. So first we will take up maximum, that is maximum value of minimum values. Okay. So what are the minimum values? So row minimums, minus 3, 3, minus 1, 1, 2 and minus 5. Now we have to take the maximum value. The maximum here is 3 plus 3. Now minimax, that is minimum value from the maximum values. So minimum values from the maximum is 4 and 6. So it is 6. Now let us see whether there is saddle point. Maximum is not equal to minimax, because maximum we have got 3 and minimax is 6. Hence there is no saddle point. So when there is no saddle point, we need to go for the next step. So what will be the next step under graphical method? It is to see whether we can apply dominance property. So next we will be try to apply the dominance property if possible. So I have rewritten the matrix here. So use dominance property if applicable. We will try to apply if we could reduce the number of rows, then we can go for the next step. So let us try here. So we can see that there are only 2 columns, hence we can reduce the rows. So for reduction of rows or elimination of rows, we will take row total. So first row total 1 plus minus 3 will be minus 2. Then 3 plus 5 will be 8. Next 5. 4 plus 1 5. 2 plus 2 4. Minus 5 plus 0 will be minus 5. So this is the row total. Now let us apply the dominance principle for eliminating the row. So first select the least total row. So which is the least total one? It is minus 5. Okay, so minus 5. So minus 5 here we need to check each of the elements and compare it to the elements of the other rows. So here it is minus 5. So here it is 2 and here it is 0. So both the elements are lesser than the elements in the next row. Hence, this row is eliminated. Then next, the lowest one is minus 2. Check here. So 1 is lower than 3, minus 3 is lower than 5. Hence, we can eliminate this column, that is row. Then next is 4. So let us check for 4. 2 here, 2 and 2 are the elements which are available. 2 is less than 4, but 2 is greater than 1. Hence, we cannot eliminate this row when compared to this row. But we can compare it with the other rows. So I will be comparing it with the next one. So here it is minus 1 and here it is 2. So 2 is bigger than minus 1. Hence, we cannot eliminate as compared to this row. Now we are left with the last row. So compare 2 with 3, yes, it is less than 3. Then 2 with 5, again it is less than 5. We can eliminate this row. Now next is 5. So any row you can select first. So let me begin with this one. So here we have the elements 4 and 1. So 4 is bigger than minus 1, 4 is bigger than 3. And 1 is lesser than 6 and 1 is lesser than 5. So this 1 is fulfilling the condition, but 4 is not fulfilling the condition. Hence we cannot eliminate this row. Next, check with the second, next 5. So minus 1 is lesser than 4, but 6 is greater than 1. We can see that 6 is greater than even with 5. So we cannot eliminate this row. Come to the last one. 3 and 5. So 3 is lesser than 4, but 5 is greater than 1. Hence we cannot eliminate it further. Now we can see that we were able to eliminate 3 rows. So next we need to rewrite the remaining strategies and assign the probabilities. So next step is assign probabilities for the remaining rows and columns. Okay, so which are the rows which have been eliminated? First, fifth and sixth. Hence B has 2 strategies and A is having second, third and fourth strategy. So second, third and fourth strategy. Let us write the values here. So you can see 3 and 5. 3 and 5 minus 1, 6, 4, 1. So these are the remaining alternatives after applying dominance property. Now let us assign the probabilities. So for 2 into n game, we will be assigning probabilities for player A because he will be having only 2 strategies. But for m into 2 games, we will assign probability for player B. So because there will be only 2 columns here. So now what will be the probability? For first strategy, y, and for second strategy it is 1 minus y. Okay, so y, 1 minus y. So now we have to find out the expected payoff function and gains under each of the payoff function. So next step here would be to calculate the expected payoff functions and gains to player B, because now we are doing it from the point of view of player B. So A's alternatives. So A's alternatives are 3, 2, 3 and fourth strategy. So we will write it here. So first alternative is 2 because 1 has been eliminated. Now we can see that what are the values here. For second strategy, it is 3 and 5. So multiply with the respective probabilities. 3 into y plus 5 into 1 minus y. So 3 into y plus 5 into 1 minus y. This will be 3y plus 5 into 1, 5 minus 5 into y, 5y, which we can further simplify as plus 3y minus 5y will be minus 2y plus 5. Now next alternative is 3 and the values are minus 1 and 6. So minus 1 into y, minus 1 into y plus 6 into 1 minus y. This will be minus y plus 6 into 1, 6, then plus into minus, minus 6y. So minus y minus 6y will give us minus 7y plus 6. Next one, fourth strategy. Fourth strategy values are 4 and 1. So 4 into y plus 1 into 1 minus y. 4 into y plus 1 into 1 minus y. So 4y plus 1 into 1, 1 minus y. So further we can simplify it, 3y plus 1. So 4y minus y will be 3y plus 1. Now let us find out the expected gain for B or loss for B. Okay. So when y is equal to 0 and when y is equal to 1. So let us substitute the values of y as 0 and 1. So first for 0, minus 2, we will write here, minus 2 into 0 plus y. So minus 2 into 0 will be 0 plus 5, so 5. And here minus 2 into 1 plus 5 will give us minus 2 plus 5, that is 3. So likewise we will do it for all. So here let us assume y as 0. So minus 7 into 0 will be 0 plus 6 will be 6. Then minus 7 into 1 will be minus 7 plus 6 will be minus 1. So same way for the last one. 3 into 0 will be 0 plus 1, 1. 3 into 1 plus 1 will be 4. Now these are the expected gains which we need to plot on a graph. Okay, so these values we will plot on a graph. So we will take a graph sheet. We will mark y is equal to 0 and you can look at the graph here. So we have two lines, so where y is equal to 0 and y is equal to 1. In between we are having the values 0.1 to 0.9. Now let us mark the values. So we can see here that the expected gain for strategy 2 of A. So 5 and 3. 5 when y is equal to 0. So 5, 1 when y is equal to 0. So I will be marking it here. And when y is 1, the expected value is 3. So 3, so this side when y is equal to 1, it is 3. Now let us join the lines, join the points here to frame a line, straight line. And let us mark it as A2. Next values to be plotted are 6 when y is equal to 0 and minus 1 when y is equal to 1. So 6 is here and minus 1 is here. Let us join the points and mark it as A3. So A3. Now last values, 1 when y is equal to 0 and 4 when y is equal to 1. So 1 and 4. So here is 1 and here is 4. Let's join the points to frame the straight line. Okay. So this is our graph which we have got after marking all the expected gains. Now we need to point out the minimax. So minimum of the maximum values. So for 2 into n games we will be plotting maximin. So it will be at the lower part, minimum of the maximum. Okay. So sorry, that is maximum of the minimum values. So it will be near the lower part. But here it will be the upper portion. Minimax. So maximum, out of maximum we will select the minimum level. So we can see that we have two. First we will plot the area. This is the area where our strategies, optimal strategies are going to fall. So let me just mark this area. So this is the area. Now we have two intersecting points. Here is one, the second one is here. So these are the, now we are pointing it from the point of view of the player who, that is A, who wants to maximize, but from the maximum value we are selecting the minimum value. So these are the points which we are getting. From this, which one is the minimum one? So minimum, we can see the one which is to the lower level. This is the point and this is the minimax point for player A. Okay, so he is the minimax player. Now just check which are the strategies which are intersecting at this minimax point. So here it is A4 and A2. So these two are the strategies which player A has to select. Okay, so from graphical method we are selecting two strategies, optimal strategies, which the player has to select in order to proceed with the game. So here with this graph we were able to trace out those two strategies, that is A2 and A4. Once we are able to find out the two optimal strategies, the next step is to find the probabilities. So for that we need to use Edems method. So with these two strategies, along with the two strategies of player B, we are proceeding to the Edems step. So let us use Edems method and try to find out the optimal strategy. So optimal strategy here is to be calculated. So let's see how to do it. So which are the two strategies? 2 and 4. So let us take up the values which are there in this 2 and 4. So you can see the Edems one which we have taken here. See, 2 and 4. The third one has been taken out from the graph method. So 2 and 4, the values are 3, 5 and 4 and 1. So I will just write it here, 3, 5, 4 and 1. Now let us go for the ornament step. Row ornaments, column ornaments. So how to find out the row ornaments? Yes, we will take the difference between these two values and write it in front of the next row. So which is the bigger value? 5. 5 minus 3 is 2. Then 4. 4 minus 1 is 3. Next, column wise. First column, 4 minus 3 is 1. Then 5 minus 1 is 4. These are the ornaments which we have arrived at. Now next is to find out the probabilities. So row probabilities and column probabilities. This probability represents the probability for player A, P1 and P2. So how to find it out? Take the ornaments, 3 divided by, add to take the total ornaments, 3 by 5. For P2, ornament is 2, then 3 plus 2, 2 by 5. Next, for player B, 4, that is Q1, 4 by 4 plus 1 will be 4 by 5, and Q2 will be 1 by 4 plus 1, 1 by 5. So these are the optimal strategies which we have arrived at. Now let us find out the value of the game. Value of the game is equal to, so I will be taking the first column, 3 into 3 plus 4 into 2 plus divided by 3 plus 2. So 3 into 3 plus 4 into 2 divided by 3 plus 2. 3 plus 2 will be 3 into 3, 9 plus 4 2s are 8 divided by 5. We will get 17 by 5. This is the value of the game. So let us write the optimal strategies. Optimal strategy of player A will be, so totally he had 6 strategies. Beginning of the problem we can see that there were 6 strategies. Of that only second and fourth he will be using, so rest will be 0. So strategy 1 0, strategy 2 is 3 by 5, so 3 by 5, 3 is again 0, fourth is 2 by 5, fifth is 0, sixth is 0. Now optimum strategy for player B will be, he had only 2 strategies, that is 4 by 5, 1 by 5. 1 by 5. And value of the game, which we have already calculated, 17 by 5. So this is how we will be solving the game problems by following graphical method. So these are the various options or methods which are available to solve a problem on mixed strategy. Hope you have understood the problem. Please like, comment and subscribe to my channel. Thank you.